Hey class, it's Professor Rourke. So I had a good question from one of the questions in the Chapter 7 review for the quiz. So just a little reminder that, the reviews are completely optional. However, they are extra credit for the next exam that we have. And also they become required if you want to use that third quiz attempt. So chapter 7 is sort of the beginning of things where things get particularly tricky. Chapter 6 did as well, but it was sort of kind of crammed in before that last test. And so we might not have had time to really let me know how many questions you had if you had them. So chapter 7 is particularly a good sort of an idea of how things will flow for the rest of the course in terms of difficulty. So please always let me know whatever questions you have. You can send me an Ask My Instructor question, or you can just send me a message on Canvas. Whatever it is that works best for you works for me. Okay, so in particular, question number 13 on the Chapter 7 review. One thing I wanted to point out that also is something that sort of kind of comes into play in these last few chapters is if we actually just look at the very top of this page, it says question 13, and then there's an asterisk, and then it says 6.2.14, copied from a different textbook, which sometimes is just helpful because the wording could be slightly different. They could have hints that are slightly different than like the verbiage that our textbook and our interactive assignment uses. Also for these, sometimes it's a little bit more annoying to open up StatCrunch. So those are all can be sort of different parts of adding some difficulties to a question beyond even just, what you're supposed to do. So that was one thing I just wanted to kind of point out for you. Another thing, I'm going to go ahead and read the question. It says that assume that adults have IQ scores that are normally distributed with a mean of 95.7 and a standard deviation of 16.2. Okay, so again, they're telling us a lot of information there. IQ scores, those are like quantitative, right? Just to kind of bring back some of that material from the first chapter. There's normally distributed, so that means there's like a normal curve, right? Follows that 68, 95, 99.7 rule. So whenever that is a possibility to come into play, I try to draw a curve. You don't have to do this, but sometimes it can just be helpful. My normal curve here looks more like a bowler's hat, but that's okay. Okay, and then it says the mean is 95.7. Okay, so that tells you the number that's going to go directly into the middle. And then we could add the standard deviation of 16.2 to the left, and we could add 3 times, and then we could subtract it from the left. I'm sorry, add it to the right 3 times and subtract it from the left, right? Okay, so we could do all of that. That was sort of back actually in chapter 3. So the new part here says, find the probability that a randomly selected adult has an IQ score greater than 127.1. And then it says, hint, draw a graph. Okay, so the hint draw a graph could have been kind of tricky because we don't normally see that word because it's from we don't see it written that way because it's from a different textbook, but it's not, like, okay, you could do that, but then what, right? Like, what do I do from here? So we're looking for an IQ score greater than 127.1. I'm being a little bit lazy and didn't actually add these standard deviations in, like 16.2. Right, we could add those in and get these values. But specifically, we're looking for the probability of an IQ score being greater than 127.1. Okay, so again, we could add 16.2 to get a better idea of like maybe where on the graph it's going to be. But this is really what they're asking us to do. And part of it, again, I think because it's in a different textbook, this is going to be the probability that like X is greater than 127.1 is how we'd write that. So we could put P parentheses, X is greater than 127.1. And we really are just going to do all of this in technology. Okay, you might have seen in this section, there are alternate ways to do this besides technology. Like back in the day when I took statistics, I would take that 127.1 and I would turn it all over into z-scores. And then I would go into the back of my textbook and there's this big table of values that they sometimes reference in chapter 7 that I would go and I would find my z-score and then I would find my area. And it was like, I feel like my days we walked to school, but no, that's how we would do it. Okay, we didn't have technology, we used a lot of tables in the back of the book. That's all we would do. Everything was like put everything in a z-score and then look everything in the back of the book. We don't have to do that here. Okay. We're going to use StatCrunch. We can also use our graphing calculator just kind of as easily, but I like StatCrunch. So the problem is there's no StatCrunch button. None at all. There's no blue square to pop it out. There's also there's help me solve this and do an example, but there's no actual StatCrunch button. So this section is where again it gets tricky. I tried to allude to it in the announcement, but sometimes you have to kind of see it and see what I'm talking about to make it make sense. So you might already have StatCrunch open from a previous question, but if not, might be an easier way. We just have to get StatCrunch open. Okay, so there's a couple of ways you could do it. You could go back to My Math Lab, and then you could click to open StatCrunch from the navigation menu. Sometimes though, it's just annoying, it will close out of your question, and then you have to reopen the assignment. But StatCrunch will be like there, open on the side of your page. So that's one option. The other option that I think I found students find more sometimes easy, is the more common route, is to go back to a previous question that had a StatCrunch button option and open it up that way. Okay, so I know it's kind of annoying because it takes a little effort to get StatCrunch there. But now once it's there, we're doing okay, hopefully. Also though, you might notice, I'm gonna go ahead and clear this drawing off. When I went back and found the StatCrunch to open, my numbers changed. Okay, so again, I'm sorry, I know it's annoying. So one option is for you to open up StatCrunch like before you even begin the assignment, and to have it there, just sort of open, ready to go in case there is no button, or to go back once you reach a problem like this and open up StatCrunch like manually. Okay, so let me know if that makes sense, or if that's difficult at all. I am, speaking of feeling old and looking up numbers in the back of the textbook, I cannot remember a number if my life depended on it. I need to see them at the same time. So this is just a little personal tip that I like to do that some of the younger folks don't feel the need to do because they can remember numbers, or you could also just write these down. But I like to click and drag my window and let it go. And then I do the same thing with StatCrunch on the other side. So it does a little split screen, and it's really nice because I can see the problem on the left-hand side of my screen and I can see StatCrunch on the right, and I don't have to worry about clicking back and forth or like messing up a number. But again, you guys are younger, you might have other better ways to do this. I'm just kind of giving you my tips. Okay. So let's go back. Now we have slightly different numbers. So let's read them again. It says, assume that adults have IQ scores that are normally distributed with a mean now of 102.2 and a standard deviation of 15.7. Find the probability that a randomly selected adult has an IQ greater than 123.5. Hint, draw a graph. So again, we already did kind of draw the graph. I erased the graph because it was different numbers now, and I didn't want to confuse you. You don't have to draw a graph. It's from a different textbook. So that's why they kind of have that. Okie dokie. So what we do here is we're going to go to stat, and then we're going to go to calculator, and everything in chapter 7 is normal. Okay. And then what we're going to do is can just enter in what the mean is 102.2. We can enter the standard deviation of 15.7. And then what we're doing is we're looking for the probability that a randomly selected adult is greater than 123.5. You'll notice that for this particular section in chapter 7, because numbers are all continuous, right? So continuous means that they're like, you could have 123.4999999, you could have 123.500001, right? There's just like an infinite number of possibilities with decimals. So it says greater than for the problem, but that is the same as greater than or equal to when we're doing continuous. Okay, so you'll see on the stat calculator on StatCrunch, for the drop down option, you can either click less than or equal to or greater than or equal to. Okay, there's no like just greater than or just less than. Okay, so I'll just double check if I have everything correctly. I have the mean is 102.2, looks good. Standard deviation 15.7, looks good. I have greater than, looks good. 123.5, looks good. And it says hint, draw a graph, but look, StatCrunch did it for us. So that's lovely. We'll take that on there. You might also notice there's an option at the top. You can click for them to show the 68, 95, 99.7 tick marks, right? So like kind of what we were talking about before, how you could have 102.2 and then you could add the standard deviation to the right and subtract it from the left. Looks like they just kind of round to whole numbers to kind of keep it easier. But this is our probability right here, 0.0874. Okay. 0.0874. So what this means is that there would be like a probability of 0.0874 that a randomly selected adult from this group has an IQ score greater than 123.5. In my mind, it's like, I think of as a percent, like 8.7%. Okay, so if I was to take a random sample from this group, there would be like an 8.7% chance that this person I picked would have a IQ score greater than 123.5. That's a pretty high IQ score, I'm thinking. So I hope this was helpful. Again, it could be a combination of things between the different textbook and the difficulty of trying to open up StatCrunch from some of the problems that are from a different textbook. So I definitely understand that. And please keep me posted. The other thing I just want to make a quick note about is the problems in this chapter are also difficult when they ask you the reverse, right? So if they're asking you to find like the number on the axis, this happens a few times. This happens when they ask us to maybe find like a critical value, like they call it like Z sub alpha. It's like area to the right, or they give you a percentile. That would be saying area to the left. So for those problems, I had a message about that, but not a particular question. That is when we would enter in numbers to the right over here. So just to kind of give a little example, I'm just going to make one up. And if this is something that's been difficult for you, then hopefully it's helped. If not, that's okay too. Okay, so let's say this problem was the same, right? The mean's 102.2 for these IQ scores. The standard deviation is 15.7. However, the question is different. They maybe say, find the IQ score for the, I don't know, 40th percentile. Okay, so let's just pretend that's the question. Find the IQ score from this group that represents the 40th percentile. Okay, so I hope this sort of makes sense that this is like kind of the opposite, because for this problem, the original problem that we were given, they said, find the probability that someone picked has an IQ score greater than 123.5. So we entered in the IQ score of 123.5 and we got out the probability. This problem is the reverse, where they want us to actually find the IQ score. And they, even though don't spell it out directly, they're giving us the probability. 40th percentile means that we're talking about the area to the left, right? That means that if we lined up everyone from the 100 people from the lowest IQ score to the highest, right? The 40th percentile means that there's like 40% of the people are to your left and like roughly 60% are to the right, right? That's what 40th percentile means, or 40th percentile for height or whatever. Okay, so for this problem, again, I know it's can be tricky and this wasn't the problem that you guys sent me, but just wanted to kind of always to sort of remind everyone because it's tricky. What we do is we have to change this inequality sign to the left because it's a percentile. Percentile means area to the left. And instead of 40%, 40% is 0.4. Okay, so what I'm going to do is I'm going to place 0.4. I'm going to enter it sort of like in where the answer typically goes on StatCrunch, on the right-hand side of the equal sign. And we click compute and we say, okay, that means that the IQ score that represents the 40th percentile from this group is like an IQ score of 98.2. Okay, so I hope I didn't totally confuse you with switching things up there. Those are the reverse versions of these problems. And again, they're often tricky. So please keep me posted through the rest of these chapters, whatever problem I can help answer, because they do get a little tricky and they can get a little frustrating. And also just kind of looking out for when they're from a different textbook can sort of be helpful to sort of add context to maybe if it's different wording than what we're used to. All right. Thank you, class. Keep me posted. I'll talk soon. Bye.